The city of Englewood, Colorado, diverts water for municipal use from the South Platte River at elevation 5280. The water is pumped to storage reservoirs at 5310 feet elevation. The inside diameter of the steel water line is 27 inches. Of elevation. The inside diameter of the steel water line is 27 inches. Its length is 5,800 feet. The facility is designed for an initial capacity flow rate of 31 centimeters with an ultimate capacity of 38 centimeters. Calculate and plot the system resistance curve. Specify an appropriate pumping system. Estimate the pumping power required for steady state operation at both the initial and ultimate flow rates. A pump in the system shown draws water from a sump and delivers it to an open tank through 1,280 feet of new 4-inch nominal diameter Schedule 40 steel pipe. The vertical suction pipe is 5 feet long and includes a foot valve with hinged disc and a 90-inch standard elbow. The discharge line includes two 90-degree standard elbows, an angle lift check valve, and a fully open gate valve. The design flow rate is 200. Find the head losses in the suction and discharge lines. Calculate the final sum total. Consider the flow system and data of problem 10.69 and the data for pipe aging given in problem 10.65. Select the pump that will maintain the system flow at the desired rate for A, 10 years, and B, 20 years. Compare the delivery produced by these pumps with the delivery by the pump sized for new pipes only. Consider the flow system described in the problem. Consider the flow system shown in problem 8.110. Assume the minimum at the pump inlet is 15 feet of water. Select a pump appropriate for this application. Use the data for increase in friction factor with pipe age given in the problem to determine and compare the system flow rate after 10 years of operation. Consider the chilled water circulation system and select pumps that may be combined in parallel to supply the total flow requirement. Calculate the power required for 3 pumps in parallel. Also calculate the volume flow rates and the calculable power required when only 1 or 2 of the pumps operate. Consider also the gasoline pipeline flow and the combined in parallel supply of the total flow requirement. Water for the sprinkler system at a lakeside summer home is to be drawn from the adjacent lake. The home is located on a bluff 80 feet above the lake surface. The pump is located on level ground 10 feet above the lake surface. The sprinkler system requires quite a bit of pressure. The piping system is to be 1 inch in diameter of galvanized iron. The inlet section between the lake and pump inlet includes a re-entrant inlet, 1 standard 45-degree elbow, 1 standard 90-degree elbow, and 50 feet of pipe. The discharge section between the pump outlet and the sprinkler connection includes 2 standard 45-degree elbows and 120 feet of pipe. Evaluate the head loss on the suction side of the pump. Calculate the gauge pressure at the pump inlet. Determine the hydraulic power requirement of the pump. If the pipe diameter were increased to 1.5 inches, would the power requirement of the pump increase, decrease, or stay the same? What difference would it make if the pump were located halfway up the hill? Water is pumped from a lake to a large storage tank located on a bluff above the lake. Determine the power input to the pump if its efficiency at the operating point is 80%. Sketch the system curve when the water level in the upper tank reaches 2 equals 90 feet.
That's fine.